we will have the sample solution released at the end of the week, which you can check. And this question is not that tricky. So the idea of merge sort is that if we have two already sorted arrays, for example, we have two arrays 1, 3, 5, 7, then the second array 2, 4, 6, 8. Both of them are already sorted. And if we want to merge them into one single sorted array, what we can do is we can have two pointers, I and j, pointing to the first element of each array. Since both of them are sorted, so the smallest element must be one of these two. So we can just do a comparison, finding out one is the smallest, so we move one to a new array. Then we increment the value of I, such that it will point to the next element. And now the second smallest element from these two arrays must be pointed by either I or j. So we just remove the first one, and the second smallest element must be the smallest element in the first array or the smallest element in the second array. Right? So in this case, we make another comparison, compare 2 with 3. And since 2 is smaller than 3, so 2 will be moved to the new array. So that's the idea of merge sort. So we can have a linear time complexity algorithm for merging two already sorted arrays. And in order to find inversions, as we discussed in insertion sort, we can see that if we place 1 from the first subarray into our result array, since 1 is the smallest element, it cannot form an inversion with any other elements in the array. And when we place an element in the second half of the second array, for example, when we move 2 to the new array, we can identify inversions like 3 and 2, that's a pair of inversion. 5 and 2, that's another pair of inversion. And then 7 and 2, that's the third pair of inversion. So it looks like whenever we take an element from the second array into our result array, that element can form an inversion with all the rest of the elements in the first array. So when we place 2 here, we know that in the original array, we would have 3 inversions. And then next step, we're going to place 3, and then we're going to place 4. And when we move 4 to the result array, we're going to say that there's 2 pair of inversions between 4, 5 and 4, 7. So the idea is that whenever we take an element from the second array, the inversion is added by the number of elements left in the first array. Then we can just modify the merge sort algorithm, and in the condition checks, whenever we find an element in the second array that we want to move into the result, we're going to increment the number of inversions by the number of elements left in the first array. I'm just going to quickly show you the modification we will need to perform on the merge function. So basically, we check the array B, an element in array B and an element in array C. If the element in array C is larger, well, element in array B is smaller, then we just move that array just as we did in merge sort. But if the element in array C, the second array, is smaller, then we add the number of elements left in the first array, which can be calculated by P minus I. So P is the total number of elements in the first array, and I is the pointer pointing to the elements that we need to do the comparison next. So P minus I gives us how many elements are left in the first array. And of course, we need to return this value at the end. Make sure that you check the sample solution at the end of the week to ensure that you understand this idea, and you can also do the implementation. Otherwise, I think this is a quite interesting and useful question. Sorry, I'm going over for 5-6 minutes. Well, that's it for today from my side. We almost covered everything that we want to cover. Thanks for joining us, and well, enjoy the rest of your week, and I will see you next week.